Okay, it's 1 o'clock Central Time again on this Tuesday, the 22nd of June. Welcome to our weekly HDF clinic. We had a few questions left over from last week, and I just want to answer them. And there weren't any questions today. I checked earlier. And oh no, before I do that, anybody who is here, do you have any questions about HDF5 or your application with respect to HDF5 and so forth? Now is the time to speak up. I will pause many more times to ask that same question, but maybe now is a good time to see if there were any questions. No? Okay, good. Then we will just press on. So the two questions from last week were, one, someone was asking about the Cache virtual object layer plugin, how it can be used and with node local storage on HPC systems. And the first thing I want to point out is, so I think that person also followed up with our help desk, but I just collected here some information for people who want to follow up on that on their own. This VOL plugin is actually not developed by us, the HDF group, but it's developed by close collaborators at NERSC, and the lead developer there is Huihuo Zheng, if I pronounced that correctly. And I added here links to this CacheVOL plugin was sort of highlighted or featured at the ECP BOF presentation. There's the hyperlink here, and it's around slide 29 if you check that. And then I also added the links here to the GitHub repository where the source code is maintained. And then we, the HDF group, maintain the SPAC integration for HDF5, but also for all the VOL plugins. And that link here is here as well. And what I also want to point out is that there, to my knowledge, to the best of my knowledge, there has been no official release of that yet. So yes, you can go there and you can check out the master branch or some other branches, and some of them may just work with a little bit of massaging. But as far as I know, there has not been an official release. It might be imminent, so I'm sure there will be an official release sooner or later. But yeah, not at this point. But then you should check up on that. How do you use it? Well, the beauty of it is really all you have to do is load that plugin, and the complexity of sort of managing your node local storage for caching purposes is really completely done behind the scenes by this virtual object layer plugin, which you would typically use in conjunction with another VOL plugin, the asynchronous virtual object layer plugin, where it basically uses background tasks or threads to move data between these local storage devices and, let's say, your parallel file system, both directions when you do read from the parallel file system to the parallel file system when you write. And so this is just a follow-up. And so the take-home message is check out, follow this GitHub repo and any announcements about an official release, and then that will be available hopefully very soon. The second open question we had was, last time I spoke about the about file locking in general, and in particular the changes, some of the changes that come in HDF 1.12.1. And one of the questions that was asked was, will these changes that are there in 1.12.1, which included mostly this best effort setting for the environment variable, but also that we do now do file locking on Windows where it traditionally was not done. Will these changes be coming to 1.10.8? And to be honest, I don't know. I still don't know at this time. So I will just keep carrying this question forward. And I hope I have an answer for you by next week, but I couldn't get a definitive answer at this point. So stay tuned. It'll be there in 1.12.1. As far as I know, 1.12.1, the release candidate is out there. Please go check it out. But I think, yeah, the release itself is coming pretty soon. Okay, I'm going to pause here and ask if there are any questions in addition to those. Okay, no, then I'll just continue and then we'll ask more questions. Here are some announcements. One announcement just hot off the press from today. There will be, last year we had our HDF Users Group meeting HUG 2020, and there is HUG 2021. In fact, there are two HUG 2021 events. One is sort of for a more European audience, and this is not so much the content, it's really the time zone difference and so forth. To juggle all these different time zones is a little bit of a stretch, so it's either too early for some people here on the West Coast or too early or too late for some people in Europe, and so there is a European HDF User Group event this year hosted by the ESRF facility in France, in Grenoble, and it will be online and it's open to everyone. It's just bear in mind when you look at the program that the timing is optimized or suitable for European audience, which is not to say if you are an early bird, then hey, this is a great time of day to listen to some of these presentations. And in fact, we still have a few slots remaining, and if you would like to give a presentation there, please let us know as soon as possible and send us a small proposal, just a paragraph, what you would like to present. And then by June 30th, if you can provide sort of a full abstract and then finally a PowerPoint presentation or PDF, whatever you need to do your presentation by July the 6th. And then I also included here all these things that are sort of bluish and underlined are hyperlinks. So if you check the notes later, you just click on them and you can follow the links. By the way, there's also, Laurie posted this on the HDF forum, and so there you have a more detailed description of this. And so yeah, here's the attendee and speaker registration, which is free, absolutely. And yeah, please go there and register. And the other one, yeah, so this is the other HUG. So this is the European HUG, and this is the sort of, call it the HUG of the Americas, more optimized sort of for people in this part of the world. And it's still open until August 1st to submit a presentation abstract, and then the actual event will take, rather than in July, when the European event is, this will be in mid-October, let's say, between the 12th and the 15th. This event here is just 2 days, and I believe one day will be more focused on sort of HDF topics, and then another day will also be HDF topics, but since it's hosted by ESRF, which is sort of a light source facility again, more focused sort of on their types of data and their use cases and so forth. But nevertheless, a great event, I think, to participate. Finally, this is also hot off the press. HDF 5 UDF version 2.1 was just released. with support for Windows and macOS. And so definitely, if you go to that post on the forum, there's the link to GitHub and so forth. Again, very exciting that we have that now on Windows and on macOS. So that's just a lot of great stuff going on here. I'm going to pause here. Any questions so far? Any questions about HDF5, your application? That's why we are here. We have plenty of interesting material to cover, but this is primarily, if you have a question, here's your chance to ask it. No? Okay, then I will just continue. So this is just another one. Maybe I should put that on the announcement. This is a link to a forum post where also in the run-up to the HDF Users Group event here of the Americas in October, we would like to have one session where we sort of collect a wish list, if you wish, of small changes, small relative, to be defined what small really means, but anything where you would say, wouldn't it be great if I could do this in HDF5? It would make my workflow, my life so much easier, and make your case and discuss it, and then we'll see what we can do. So that thread is still open and had some very interesting contributions already, and we just keep it open for the next several months, pretty much until the event, and then we will sort of bring them all together in one presentation. Okay, then there was another interesting post earlier this week, I believe, must have been yesterday or Sunday. A user was reporting that he or she was creating a lot of attributes and noticed that initially just a few hundred attributes, that was fine. And then there was sort of a gradual slowdown over time in creating or writing. I believe the user said writing, although I'm not sure if he his or her time reporting included just the writing time or the creation plus the writing time. It's not that important. But yeah, they noticed a substantial slowdown by like an order of magnitude. I think the first time it was like 7 times slower, and then it was 10 times slower. And once they reached sort of into this range of 10,000 attributes, 100,000 attributes, and so forth. Now, if we get to it, today's tips and tricks and insights, we will show that there is sort of a low-level trick, if you wish, that might fix some of these issues, but at the end of the day, there is no magic bullet. It's really it's really a question: is it a good idea to have hundreds of thousands, let alone millions, of attributes that, in a way, I would say, from the point of view of the data model, not exactly defeats the data model, but it uses HDF5 in a very unusual way that I think the people who designed it didn't really anticipate or didn't think that that was a particularly interesting use case. And the use case, so what you would use attributes typically for would be what you might call user-defined or application metadata. So let's say you have a data set, and that data set is, for example, a time series. Then a piece of descriptive metadata, as people call it, of the time series might be, for example, the sampling rate, if it's constant. I mean, if it's not constant, if it's variable and so forth, then you might want to record maybe the unit of that physical quantity that these samples, in which these samples are measured. And or if you provide timestamps, some information about the reference system for that time series. But so I think all I'm getting at that even if this is this type of descriptive metadata, I think the fathers of HDF5, when they thought about that, they thought that would people have a dozen such attributes? Yeah, very likely for a very complex data set and so forth. There might be plenty in the sense of dozens of that type of descriptive metadata that you would like to store. But if you get into the range sort of thousands, of tens of thousands, you're really, again, in that sense, the customer is always right. If that's your use case, then that's your use case. I would challenge you, though, that if you are interested in any kind of efficiency, and the efficiency means the storage efficiency itself, but also the access efficiency, so storage efficiency in terms of the size, but also the access efficiency in the sense of how long does it take you to read one of these attributes or write one of these attributes. There are much more efficient ways to represent that in HDF5 without attributes that I would prefer. On top of that, again, attributes, they look a lot like data sets, and they are array variables in that sense. They can be multidimensional. There's an element type to them. That's all great. But unlike data sets, you cannot compress them or filter them in any shape or form. You cannot do partial I/O on them. So if you have a multidimensional array and you would like to read just a region or a certain strided pattern or something like that, you can't do that with attributes. And if the value of such an attribute is fairly sizable, you cannot do random access on that. You really have to read the entire attribute, and you can't just read parts of it, or if it's a compound type, just a particular field. So in my opinion, this is kind of a corner case. If your type is extremely simple and so forth, maybe, but then again, once you get into the thousands and tens of thousands and so forth attributes, there is really an issue with how they are stored in the HDF5 file. And that's where this technical detail that I'm going to talk about in a moment comes in. That actually came up during the development, the main development of the 1.8 series of release branches, that people started having quite a few attributes and so forth, and the traditional sort of, I believe it was called compact storage of these attributes was a little bit of a bottleneck, and an additional way of storing, an alternative way of storing these attributes was introduced, and so that you can manage them more efficiently. And this is what this low-level fix, it's basically a file format change, was about. And I will show you in a moment how to enable that. And yes, as a side effect, it will give you better performance. So the slowdown, instead of seeing 10,000 attributes being 7 times slower than 1,000 attributes and 100,000 being 10 times slower, okay, you will maybe see some improvement there, although there is going to be a slowdown, generally speaking, because if you write more, it's just going to take longer. It's just in terms of the data structures, the underlying data structures that are used, it's going to be more efficient and so forth. But in the end, it's not going to do any miracles. So the fact remains that if you have hundreds, if you are contemplating hundreds of thousands or millions of attributes, I would say that's not a great idea. And you should think about, or ask on the forum, or come to the next clinic, and then we can talk about better ways of organizing your data and give you efficient access and sort of help you to achieve your goals. Anyway, that was just a long-winded way of saying, let's talk. I'm going to pause here, but I have a little bit of a tips and tricks and insights here that we can talk about if there aren't any questions. So I'm going to pause here and ask, are there any questions out there? Is there something that somebody would like to talk about? Otherwise, we'll just move on with this. No? Okay. So we'll just move on. So this is something that comes sometimes up in the forum, in comments and so forth. And it's actually good to talk about this question about versions, and then is there, how many HDF5 file formats are there versions, and yada, yada, yada. And there is some confusion, some of that confusion we've created, and some of that confusion was created by others by maybe not reading our documentation that carefully, and maybe our documentation isn't perfect either. Okay, talking about versions. There are fundamentally two types of versions that you will typically encounter with HDF5. Obviously, the HDF5 library version. So currently, the 1.8 among the supported versions, we have the 1.8x family of versions. I believe 1.8.22 is the current for 1.8. 1.10.7 is the current one for the 1.10 family of releases, and 1.12.0, soon to be 1.12.1, is the latest release of that family of releases. And then we also periodically version the file format specification. And that is really the version, if you wish, of the file format specification. I would not call this the file format version, because that file format version that people then imagine is there, that there is in the file format representation, there's somewhere a version number that says, oh, this is HDF5 file format version such, and that's not true. The file format is really versioned, not the file format as a whole, but individual pieces in the file format, how certain primitives are represented. There are micro versions for those, and now you could create sort of cross sections of this, or sort of ranges of these micro versions that combined make a file format version, but that typically doesn't make sense, and it's not done like that. So what's versioned with respect to the file format is really just the specification, and then what you can do is you can say, well, a certain library version or may support a file format specification 2 or 3, or the different versions that are out there. To put that a little bit in context where this plays a role is, and again, something that is frequently overlooked or not very well stated, is this HDF5 library forward and backward compatibility. What does that mean? People typically have no problem understanding what backward compatibility means, but then with the forward compatibility, it gets a little iffy. So let's talk about backward compatibility. And this is compatibility for the library. So backward compatibility of the library means that if I take the latest version of the library today, which would be, if I ignore the development branch, it would be 1.12.0. That means that that library 1.12.0 can read HDF5 files, any HDF5 file that was created with all earlier library versions. So 1.12 can read files, obviously, that were created with 1.12, but also with 1.8, with 1.10, with 1.6, any of those releases. That's backward compatibility, and that's, I guess, easy to follow. Forward compatibility is a little more complicated, and that comes from this idea that, yeah, there is no file format version. I guess that's basically where that comes from. And the forward compatibility means I have a library version installed. This is what I call the given version. And a friend of mine or colleague gives me an HDF5 file, and I would like to read this file. And then the question is basically, well, when this colleague created that HDF5 file, did they create this with an older version compared to mine of the HDF5 library, or did they create that with a newer version of the HDF5 file? Okay, because of backward compatibility, there would be never an issue with an older version of the library. But let's assume they have installed a tool that used a slightly or newer version of the HDF5 library. And then the question is, can my library read that HDF5 file? And the answer is, it depends. My version of the HDF5 library will be able to read this HDF5 file without any problems, as long as the primitives, the features of the library that were used in that newer version of the library are compatible with the range of features, so to speak, that my library supports. So as long as they created that file and didn't use any specific features that would render it not readable or not comprehensible by my library, there is no problem. So you can have a 1.8 version of the library, for example, and somebody used 1.10 or 1.12. They didn't make any fancy adjustments. They're not using any specific features to those versions that would destroy that range compatibility of library versions. There's absolutely no problem. If you create an HDF5 file with these newer versions, then there's no problem whatsoever. And this is what we call forward compatibility, that a library can read HDF5 files created by newer versions of the library, as long as they are feature range compatible, so to speak, with that version. And of course, if something is included there that is not compatible, then this library, when you try to read those objects, for example, it will just return an error and say, no, I'm sorry, I don't know anything about this object, which I think is the correct behavior. Now, the default is, if you don't make any adjustments for that any HDF5 library, sort of the 1.8.22, the 1.10.7, the 1.12.0, 1.12.1, they always are configured by default that they the sort of the lower bound of that feature range is the earliest version. So that way, we in a way maximize the chance that a file created with the latest version of the library will produce HDF5 files that can be read with as many as possible older versions of the library. Again, only if you use features specific to that newer version of the library that didn't exist back when, then you will have trouble accessing those. But otherwise, there will be no problem reading those files. Now, the gentleman here that reported this performance problem, again, there was an adjustment made to the storage layout of attributes in one of the 1.8x versions of the library, that unless you trigger that you want to use that feature set, you will not, the library will not use, because again, it wants to maintain that forward compatibility for older versions. But you can intentionally advise the library and say, I know there is this feature, I would like to use this feature, and I want to force you to really use this newer layout for attributes. And here's how you would do that. So this is basically a simple C program that prints the library version. So when I compile that, my default library version is 1.12.0. So it would print, it would say, welcome to HDF5 1.12.0. And then you create what's called a file access property list. And in this file access property list, you can set that range of library versions that applies for object creation and access that you want the library, your current library, so in my case 112.0, to use. So it's this call H5P set libvirt bounds, where you can sort of set the lower bound for that range, where you say, I want to take advantage of features that that were introduced in this release. If there were earlier versions, ignore these. I really want you to take advantage of these newer features. And you can also cap that from above, but in my case here, in this particular example, I'm saying use the features that were compatible with the 1.8 sort of family of releases, nothing earlier. And I'm not going to cap it from above, so I'm not restricting it. If I wanted to confine it to strictly 1.8, I would set the upper bound also to libvirt v1.8. But in this case, since this is a 1.12 version of the library, when I compile it, libvirt latest would be 1.12.0. And then that's all you need to do. So when you create or open your file, you would pass to that, in the case of create, that first argument is the file creation property list in the case of create. But if you just open it, there would be a file access property list argument, and you pass that in there, and that advises the library to behave with this sort of feature range selection, so to speak. And then you just do things with that file. So in the case of the person with the many attributes, if you now go out and create all these attributes, since the library was configured to use the 1.8 library version compatible feature range, it would use that more efficient layout for large numbers of attributes. And so that's how you would trigger that. And that's all I had to say. Obviously, in the C example, it looks more complicated than it really is. In some of the modern language bindings, be it Python, Julia, H5CPP, and so forth, it's a piece of cake. It's just a keyword argument somewhere rather than having to write a lot of code. But this is C, and this is all the boilerplate that you have to write. But at the end of the day, it's not very complicated. And if you have more questions, ask a question and come back next week. We are out of time. And thanks for coming, and I'll see you next week. Thank you.